This is R.D. Sharma solution, class 12th, chapter 9, continuity. Exercise 9.2. Find the points of discontinuity, if any, of the following functions. So there are certain things you have to write up front, and these are the modulus function or absolute value function. This is continuous. We know about that. We discussed it earlier. And this function is a polynomial function. And since this x square, 3x and 13, all these are individually continuous functions because they are polynomial functions. So we can say that these are polynomial functions and absolute, so they are continuous. So we have to check at x equals 1. So when we go, on the left hand side, we will use this function. On right, we are going to use this modulus function. So one time polynomial, one time modulus. So x equals 1 minus h on the left, x equals 1 plus h on the right. So this is 1 minus h whole square by 4 minus 3 into 1 minus h divided by 2 plus 13 by 4. This is x equals 1 minus h. Now let us place x equals 1 plus h. So 1 plus h minus 3 it is. So rather opening it and keeping h equals 0, you can directly put limit h tends to 0 in both the sides. So this will be 1 by 4. This will be 3 by 2. This will be 13 by 4. Okay. When you take the LCM and solve it, it is going to be 2. On the right hand side, h is 0. So 1 minus 3 is negative 2. And when you take the modulus, it will be 2. Okay. Now left hand limit and right hand limit, they are equal. But still one more thing has to be checked at x equals 1. So this will be mod x minus 3. So f1 we have to find out because this is the equality sign. And for this we are going to use this mod x minus 3. So 1 minus 3 it is, again minus 2 modulus, so it will be 2. Now what you see here is the left hand limit and the right hand limit, and the value of the function at 1 is 2. That is, this given function is continuous because all these are continuity points. Find the points of discontinuity, if any, of the following functions. Okay, so there are 3 separate functions, and these separate functions are individually, they are continuous. We have to check at 3 and minus 3 as well. That is, if you start with this real number real line, so 0, just to show that how the line goes, negative 3 on the left hand side, positive 3 on the right hand side. Okay. So when x is less than minus 3, when you go this side, on the left hand side, you are going to use mod x plus 3. When you go up minus 3, that is on the right hand side of minus 3, so you are going to use minus 2x. And please remember, all these 3 functions are individually continuous that you have to write. That you can write. I hope you will be able to do that. Okay. Because mod x is continuous, 3 is a constant function. So when you add it, then also it will be a continuous function. We have minus 2x. This is also a polynomial function. Basically, you can call it as a straight line also. 6x plus 2 is also a straight line, but it is also a single order polynomial function. And we know that they are continuous, right? So this you have to write from here to here. All these points you have to mention here. This is mandatory. And then you come to the point at minus 3 and 3. And you need to check at both the points. Okay. So minus 3, x equals minus 3. And what we are going to do is left hand limit and right hand limit. What is left hand limit? Because it is negative 3. So x will be negative 3 minus h. Right hand limit will be minus 3 plus h. Okay. Now this is minus 3, and you have to do this same activity for plus 3 also. This is minus 3 minus h, we are using mod x plus 3. Here we are going to use minus 2x, we are going on the right hand side. So it will be minus 2 into minus 3 plus h. Okay. Either you put h directly here as 0, or you can open it and keep it h equals 0. Both ways you can do. So the best idea is to take 0 here only, because there is no other simplification possible. It will be negative 3, negative 3 modulus is 3, 3 plus 3 is 6. Here it is 0, so minus minus plus reduces 6. Okay. The left hand limit and right hand limit, they are equal. Now equality sign is at mod x plus 3. So let us check it. The value of the function at negative 3, it is mod x plus 3. So mod, put it minus 3 here. Negative 3 will be positive 3. And we have a 3 here. So this is going to be 3 plus 3, which is going to be 6. Okay. Now what you see here is all the three values are same, and this is the point of continuity. This function is continuous at x equals minus 3. How about checking it at 3? Because both the points you have to check. So LHL, what are we going to write? LHL will put 3 minus h. RHL will put 3 plus h. And left hand limit, right hand limit, 3 minus h, 3 plus h. So minus 2 into 3 minus h will put here. And right hand side 6x plus 2, we are going to use this function 6x plus 2, because we are taking the point of contention is 3, so left right of that, and accordingly we'll use the function as 6 into 3 plus h plus 2. Now put h as 0. What do you get? Minus 2 into 3, so minus 6 it is. And then we have this 0, so 6 is 18. 18 plus 2. So do you think there is any need of checking the value of the function at 3? Because the left hand side and right hand side, they are not equal. When both the values are not equal, you can very well say that minus 3 is the point where there is a discontinuity. But still we'll check for f3. This is 6. Equality sign is where? It is not given. But just assume that it is at x greater than or equal to 3, 6x plus 2. So 6 into 3 plus 2, that is 18 plus 2, that is 20. So it is matching with the right hand side, right hand limit. But still the left hand limit and right hand limit, they are not matching. So when they are not matching, you can very well say that 3 is the point of discontinuity. And on the other hand, minus 3 is definitely the point of continuity. So there are several questions like this, and I will encourage you to check for both the points of contention, not just one. Okay, you see in the solution it is only being checked for 3. Find the points of discontinuity, if any, of the following functions. So fx is this. So let us, first of all, you have to write all these. X to the power 10 minus 1, x to the power 10 is a function which is continuous. Then 1 is continuous, x square is continuous. There are certain ways also, you see on the left hand side I have showed you. This is also a way to actually solve this type of question. But we will do what? We'll follow the same routine or the procedure we used to follow in the earlier discussions. So x10, 1, x square, x10 minus 1, all these are continuous. But we'll check the discontinuity at x equals 1. And we'll go on the left hand limit, we'll use x raised 10 minus 1. On the right, we are going to use x square. So we'll check at 1, so 1 minus h on the left hand side, 1 plus h on the right hand side. So we'll put this x 1 minus h to the power 10 minus 1. Here we'll place 1, this is x square, so 1 plus h whole square. So this, just put h as 0 here on the left hand side and right hand side, so it will be 1 raised 10 minus 1. So 1 minus 1 is 0. Here h is 0, so 1 square is 1. Okay. Now 0 and 1, they are not equal. So would you like to find out the value of the function at 1? It is not required, but just for the sake of completion we have to do. So we will find out the value of the function at 1, that is f1. It is x raised 10 minus 1. So just put 1 raised 10 minus 1. So this is also going to be 0. 1 minus 1 is 0. But still all the values are not equal. That means this 1, x equals 1 is the point of discontinuity. Okay, I hope you got the idea. It is point of discontinuity. Find the points of discontinuity, if any, of the following function. So I'll just leave it for you. I hope you'll be able to do this question. So you have to check it for 0, you have to check it for 1. Both points check. 2x polynomial, 4x polynomial, 0 is a constant function. So they all are continuous. Find the point of discontinuity, if any, of the following function. Fx is sin x minus cos x when x is not equal to 0, and sin x is continuous, cos x is continuous everywhere, and when we have fx and gx as sin x and cos x, fx minus gx, which is sin x minus cos x, this will also be continuous. This you can very well write. Along with this, we have when x is equal to 0, then it is given as -1. -1 is a constant function. So all these three are continuous by themselves. But we have to check the continuity or discontinuity at x equals to 0. So we'll go on the left, it is 0 minus h. We'll go on the right, it will be 0 plus h. So it will be sine, let us put it here. Sine, in place of 0 minus h, just you can replace it by minus h. So sine minus h minus cos minus h, here it is -1. So you don't have to do anything here, it will remain as constant. Sine minus h, sine minus theta is minus sine theta. So it is minus sine theta, minus sine h. Cos minus theta is plus cos theta. So it will be cos h. What is this? Sine 0. I am applying the limit here. It is going to be sine 0 minus cos 0. Now sine 0, cos 0 is 1, sine 0 is 0. So 0 minus 1 will be equal to minus 1, -1. So -1, both the sides. One step is still remaining. We'll check the value of the function at x equals to 0. And it is already given as -1 in the question. That is, x is 0. So you don't have to do all this, which I am doing right now. It's already given at x equal to 0, the value is -1. So -1, -1, -1, all these are same. So it is continuous everywhere. So this is also the same type of question. Okay. So -2, 2x, the -2 is a constant, 2 is a constant, 2x is a first order polynomial, and these all are continuous. This you have to write everywhere. Okay. But you have to check the discontinuity or continuity of this function at x, which is equal to 1, and x equal to -1. So these are the 2 points. So accordingly you have to choose the function also. So x -1, when you go on the left, it will be -2. X equals -1 minus h we will put. X as -1 plus h will put. Left hand side, don't worry about that because it is already a constant -2. But on the right, what it will be? It is -1 plus h, so 2 into -1 plus h. So it is -2 already on the left hand limit. Apply this right hand limit h0, so it is -2. So LHL and RHL are equal. Okay. So f -1, the value of the function at -1, it is already given as -2. LHL, RHL and the value of the function at -1 is -2. So this function is continuous at x equals -1. But whenever we talk about x equals 1, then we have to check there also. On left hand side, we are going to take 1 minus h. On right hand side, we are going to take 1 plus h. And when x is less than 1, it is 2x function you are going to use. On right, you are going to use 2. So 1 plus h you cannot put here. So it will remain as 2. Here you can put 2 into 1 minus h. So just apply the limit h equals 0. So it will be 2. 2 here, 2 here. And then we have the function value at x equals 1, which is already given as 2. So LHL, RHL and the value of the function at 1, they all are 2. So what do we find here? that at x equals to -1, x equals to 1, both ways, these functions are continuous. This actually fx function is continuous everywhere. All these you have to write, okay? That is -2, 2, constant function, 2x, polynomial function. This all you have to write. Okay, next is in the following, determine the value of constant involved in the definition so that the given function is continuous. Now, as per the definition goes, sine theta is continuous. 5x polynomial function is continuous. 3k is a constant. K is some constant. So we'll just apply the limit x tends to 0 for sine 2x by 5x, and we'll equate it with the value of the function at 0. So f0. But the value of function at 0, f0 is nothing but 3k. It is already given in the question. It is 3k. So we'll apply the limit here and equate it to 3k. So sine 2x it is, we need to have a 2x in the denominator, or x is already there, we'll include a 2. Or we'll introduce a 2. So it is 2, x was already there. Now we have a 5 in the denominator, so 2 has to be taken up also because this 2 should be cancelled. Okay, now apply the limit. Taking 2 by 5 outside, so limit to sine 2x by 2x. Okay, this is going to be 1. We know that sine theta by theta, limit theta tends to 0 is 1. So 2 by 5 it is. And it has to be equated with 3k. So k will be equal to 2 by 5 into 3. 2 by 15. K is 2 by 15. This is your answer. Okay.